Welcome back, everyone. Today we're going to talk about matrix multiplication and how to do it. So in this first example, it says to find AB and BA if possible. Now there's a couple things I want to clarify here. So how come we have to multiply AB and BA separately? Aren't those the same thing? And the answer is when it comes to multiplying matrices rather than just multiplying regular numbers, the answer is no, that they are not going to be the same thing. Or if they are the same thing, it'll be coincidence because in general, AB does not equal BA when A and B are matrices. Okay. The other thing is it mentions if possible, and that's because it's not always possible to just multiply any two matrices together. In order to be able to multiply two matrices together in the first place, we have to make sure that the number of columns in the first matrix, so matrix A, in this case, if we're doing AB, is equal to the number of rows in the second matrix, so matrix B, in the case that we're multiplying A times B. Now, in this first example, both of these will be, since it's two square matrices, it will be possible to do both ways to find both AB and BA, but sometimes it's not possible to find both of them. Sometimes it's just possible to find one of them, depending on the size of the matrices. And other times, it's not possible to find either of them. And so that's important to keep in mind. Okay, so first we're going to figure out what A times B is. So for that, I'm going to write A here, 3, 4, 7, negative 2. And then I'm going to write B up here, 2, negative 1, negative 3, and 6. And then I'm just going to draw lines like this. And this is going to be my new matrix. Okay, so then what I'm going to do is I'm going to take the first two here. So I'm going to look at this number and multiply them, and then take this number and multiply them, and then add my results together. So for this first square here, it's going to be 2 times 3. I'm going to write that down, 2 times 3, plus 3 times negative 4. So plus 3 times negative 4. And that's equal to 6 minus 12, which is equal to negative 6. So negative 6 goes in that first slot there. Okay, now let's do the same thing for the second one. Negative 1 times 3 is negative 3. So negative 1 times 3. And then here we have 6 times 4. So plus 6 times 4. That's equal to negative 3 plus 24, which is 21. So 21 goes here. Okay, now let's do the same thing for the bottom left one. So that's going to be 2 times 7, which is 14, plus negative 2 times negative 3, which is 6. So 14 plus 6 is 20. And then for the last one, negative 1 times 7 is negative 7. And negative 2 times 6 is negative 12. So we're going to get negative 7 plus negative 12, and that's going to be negative 19. So the answer here is negative 19. All right, and so therefore we can conclude that since this is A right here, and this is B right here, that A times B is equal to negative 6, 21, 20, and negative 19, like that. So this is the matrix that's equal to. Now we're going to do B times A. So we know B is equal to 2 times 2, negative 1, negative 3, and 6. And A is going to go up here. It's going to be 3, 4, 7, negative 2. And we're going to just use the exact same method we used before to figure this one out. Okay, so just to review which numbers that we're going to multiply and add, we're going to multiply 3 times 2 to get 6. We're going to multiply 7 times negative 1 to get negative 7. And then we're going to add those results together. So 6 plus negative 7 is negative 1. Then we have 4 times 2, which is 8. And then plus negative 2 times negative 1, which is positive 2. So 8 plus 2 gives us 10. So the answer is 10. All right. Then we have, for this next one, we're going to have 3 times negative 3, which is negative 9, plus 7 times 6, which is positive 42. So 42 minus 9 would be 33. Okay. Then we have 4 times negative 3, which is negative 12. And then we have plus negative 2 times 6, which is also negative 12. And negative 12 plus negative 12 is negative 24, like that. So therefore, BA is equal to negative 1, 10, 33, negative 24. So not only did we not get the same answer for the second matrix, but actually none of the entries in either matrix were the same. So it's very important to remember that multiplying matrix A by matrix B is not the same thing as multiplying matrix B by matrix A, and I see this mistake all the time as a teacher. Okay, next let's move on to finding CD and DC if possible. So first of all, are both of these possible? Well, in order for this to be possible, to multiply either one of them for any two matrices, the number of columns in the first matrix needs to be equal to the number of rows in the second matrix. And the reality is, for these ones, that for C, the number of rows is 2, right? C has 2 rows and 3 columns. And D has 3 rows and 2 columns. So when it comes to C times D, is it true or is it untrue that the number of columns of C is equal to the number of rows of D? And yes, that is the case, because here we have 3 columns for C and 3 rows for D, and so that is the same number, and so we can do C times D. So since we can do C times D, since we've determined that, I'm going to go ahead and figure that out. So I'm going to put C here. Actually, I'll put it a little bit lower just to give myself a little bit more room. Okay. And notice we're going to end up with a 2 by 2 matrix as a result of this. Okay, so first we need to do 2 times negative 3, which is negative 6. And then 5 times 5, which is 25. And then 8 times 2, which is 16. And if we add all those numbers together, what will we get? Well, let's see, we'll get 35. So 35 goes there. Then for the second slot, we have 2 times negative 1, which is negative 2. Then we have 2 times 5, which is 10. Then we have 2 times 10, which is 20. So overall, we're going to get that that is equal to 28. So 28 will go right there. All right, and then for our next one, we have negative 3 times negative 1, which is positive 3. And then we have 5 times 6, which is 30. And then we have 8 times 3, which is 24. So this is overall going to be 57 for that one. So 57. And then for the last one, negative 1 times negative 1 is 1. 2 times 6 is 12. 10 times 3 is 30. So therefore, we're going to get 43 as our answer. So therefore, CD is equal to this matrix right here. Okay, the next thing we need to do is we need to figure out DC if possible. So first of all, is it possible? Is it true or false that the number of columns in the first matrix, in this case D, is the same as the number of rows in the second matrix. And yes, because matrix D, the first one, does have 2 columns, matrix C has 2 rows. And so the answer is yes, absolutely. We can multiply them. I'm actually going to grab another page here for us to multiply them since we don't have a lot of room here. Poof. Okay, so DC, we're going to put D over here. Actually, let's put a little lower down. -3, -1, 5, 2, 8, and 10. And then over here, we'll have C, 2, 5, 2, -1, 6, 3. And so notice the resulting matrix is going to be a 3 by 3 matrix. So not only is this matrix going to automatically definitely be different from CD, but it's not even going to be the same size, right? We already found CD and it was a 2 by 2 matrix. And this one's going to be a 3 by 3. Okay, so let's multiply it out and figure this out. 2 times -3 is -6, plus -1 times -1 is 1. -6 plus 1 is -5. Then we have 5 times -3 is -15. 6 times -1 is -6. So -15 plus -6 is -21. Then we have 2 times -3 is -6. And then 3 times -1 is -3. And -6 minus yet another 3 would be -9. Then we have 2 times 5, which is 10. And then -1 times 2, which is -2. So we have 8 there. And then we have 5 times 5 is 25. And then plus 6 times 2, which is 12. So 25 plus 12 is 37. Then we have 2 times 5 is 10. Plus 3 times 2 is 6. So that's 16. Then we have 2 times 8 is 16. And -1 times 10 is -10. So 16 minus 10 is 6. Then we have 5 times 8 is 40. Plus 6 times 10 is 60. So 40 plus 60, that's 100. Then we have 2 times 8 is 16. Plus 3 times 10 is 30. So 16 plus 30 is 46. So therefore, our matrix DC is this matrix: -5, -21, -9, 8, 37, 16, 6, 146. And there we go. As always, please do leave any questions you might have on this in the comment section, and we'll see you for the next one.